Just play the new one. The new one is for the one for the people that the old one is for.
What the hell is this happening?
That was interesting. So let me take a look at Eclipse and see what you might be running into. So I just Googled Eclipse download and clicked through on that.
You're getting errors telling you that it's like an outdated JDK or something?
He's getting errors saying that he doesn't have a JDK.
Oh, I ran into the same problem. It told me I had 6 when it was requiring 8 and I've installed 8.
Oh, okay.
Recognize it? And it turns out you have to install like the full version.
Yeah, so I think you just do the default download.
Well, that's what I did. And
Okay.
then you go to a mirror, and then you download that.
Mm-hmm.
And I tried installing, and it says, oh, you don't have these. So I installed those prerequisite files, and then it says, I still can't download it.
Are you on Linux or Windows?
Windows.
Windows, okay. And you have Java JDK, you said, right? I don't know, I can look at it with you offline and see if we get it to do it.
I'll try and play around with it.
Okay. You could always try,
I tried running with that, and
yeah, you can try uninstalling Java and then doing Eclipse, but that's never been necessary for me at least. But
No, seriously,
It's never
there's
the
one that
same
was
choice.
like, right, do your signature with the mouse button. And I was like, oh no. I kind of like this one best.
all right, how's everyone doing today? So how'd ODP 300 work? Any issues with that?
My screen greeted the world. And then
Cool.
Other than you wanted exact spelling. So.
Yes. Yeah.
Yeah, I actually messed that up too.
I have a question about the left one.
Yes.
Like, can you explain about the expanding?
Expanding the memory?
Yeah.
Yeah, let's just go ahead and do that.
I mean, before the expanding, our memory was 3.8.
Okay.
Right? But after expanding, it was 7 gigabyte point 5.
Okay, that's good.
Is it possible?
Yes. Did you try doing it again, see if you get even more?
Didn't try to do that. That's for this machine.
So it's not really magical, right? It's just that for some reason the way that the operating system gets installed on the SD cards, the way it's partitioned or something, when you first boot up and you use this operating system is called Raspbian, it's not set up to use the entire SD card, right? So if you have, I think, a 4 gig SD card, it might be using all of it, but if you have a 16 gig, most of it's unused. And so this is just a bundled way to basically change the partition table to take up the maximum amount of space available. So it's just a front end to a utility for you. That's all that's going on with that. And you could do it manually if you do like fdisk-l, it will show you information about the different partitions. Well, we can't run gparted, but there's different commands you can use to play with a partition table, and they should have manual pages on them if you want to dig into it. And I think that option in raspi-config is just a front end to some of these commands. I don't know what I just did to my system though, so I'll reboot it and make sure it still works. So yeah, ODP 300 was a bit of an oddball compared to the others because it was a warm up to the ODP, so I was just having you print something, and in programs where you're just printing something, the output has to match exactly. So if you had a lowercase w versus an uppercase w, right, you can get 0 out of 10 for that. But the other ODPs won't be like that. You'll be creating a class that does something with some data or does some manipulation and so on. It won't be output based. Your ODPs generally won't produce any output. And so the assessment isn't bound to, you know, did I put an extra space in here or something like that. So they shouldn't be as goofy down the road.
Absolutely no warranty.
Absolutely no warranty. Did anybody here try overclocking their Pi? Did it work?
You cannot overclock.
Okay. Yeah, because someone tried that in the other section and it said it was not overclockable, which is a bummer because everything should be overclockable.
Liquid bullet.
Yeah. If anybody's taking 270 in summer, overclock your PIC processor. I'm waiting for someone to do that. It's easy to set up, right? Because you can put in your own clock.
That's a fail.
And yeah, you can put in your own clock, and it's supposed to go up to like 40 megahertz, but crank it up. See what happens if you get it up to like 400 megahertz. All right, other questions? So what I want to do today is talk about the next ODPs. So 301 is out right now. That's due tomorrow. 302 will post tomorrow morning and be due on Friday. So I want to talk about the ODPs. And I want to talk more about classes and objects and go through some detailed examples that will lead you into the third ODP. And then I want to talk about programming assignment 1, which is due a week from Friday. And after today, you will probably know enough to do programming assignment 1, so, or at least to make a good start on it. So I want to go through the details of that so that we're done with that this week. So let me hop over to the server. And look at ODP 301. So ODP 301, you're creating another class named myClass. These classes will tend to be called myClass. Why? I don't know, because I lack imagination. But not bad strategy is to do something like make yourself a directory called ODPs, or whatever you like. And inside that directory, make a subdirectory for each of your ODPs, right? And it lets you do things like if you want to copy the README, you can put that in there. If you want to write your code, you can have the code just associated with that ODP in its own directory. And it's a mindset that's pretty common in a lot of what you're going to encounter. For example, in Eclipse, every time you start a project, it can be in its own directory. And there's usually a whole tree of subdirectories with, you know, dozens or hundreds of files, depending on your environment, associated with that one project. If you did any of the FPGA, any of the Verilog stuff in 250, if you took 250 already, same idea. When you start a project, there's all these files that get created. Or in MPLabX, right? You put two projects in the same directory, they tend to conflict with one another. So your class here is going to be called myClass. And we've already done this on Monday. We wrote some code like this. So myClass is a class that just contains a single integer variable named x. And it has one constructor which you pass an integer to, and the constructor sets x equal to that value. So myClass, you can construct it by saying myClass 17, for example, and that should create an object of type myClass, and it should set x equal to 17. And this is not part of your ODP. This is code that you might use to test your class. Okay, it's similar to what the assessment system is going to use. So here's a main program, public static void main, and it defines a variable of type myClass. The variable is called MC, and it constructs it in the same line that declares it, sets MC equal to a myClass initialized with an argument of 17, which should set the x variable to 17. And then I do a print line, and I say print out the value of field x in MC. That should print 17. And then down here, I say MC.x equals 23. That should change the field's value. And now when I print MC.x, I should see 23.
Why didn't you use the word new?
New is a keyword, so it's kind of like malloc. Okay, so new my class is kind of like malloc size of my class. It's saying that I want to actually construct an object of whatever class name follows it. And it's a very particular keyword in the Java language. All right, so if you write your myclass.java file and it compiles successfully, and you write something like this and compile it, and it compiles successfully, and you run it, and it prints 17, then it prints 23, your myclass is probably correct, in which case you can go ahead and assess it, and the assessment is always going to look something like this. Assess the name of the test bed, which is temp mymain301, and the name of your Java file, which is myclass.java. And this will only work if you've already compiled myclass.java and you have myclass.class sitting in your current directory.
You put that main in a different .java file?
Yes, yeah.
And then when you're compiling it, you just still only need to do the myclass.java, or do you need to do both of them?
So let's see. So I've got a myclass.java. So I'm just going to call this main. So I'll compile main.java, and when I did that, it also compiled my myclass.java. Okay, so I can say java main, and it goes ahead and runs that. Now, let's stick to an uppercase. Right, this will work perfectly well too. So it's a class called haha .java, and I can run it with Java haha.
So you only need to compile like the main program or the main file?
It's automatically going to compile the myclass.class.
If you compile the myclass.java, is that going to compile the haha.java?
I don't believe so. Right, because it doesn't depend on main or haha. But haha reads myclass.class, so it'll compile it for you.
Sweet.
So it's a little bit makefile-ish almost. But, you know, your goal is to develop the class file, so you're probably going to want to compile it yourself to make sure there's no errors and such. But sometimes you compile something and you get a bunch of errors from other files, and it's because they're dependent on one another.
It's convenient.
Yeah, it is. All right, so that's ODP 301. So it's just a class with a variable and a constructor. And we'll talk about ODP 302 in a little bit, because it's going to be an embellishment of 301, but I want to talk about those embellishments in here first. All right. Well, so we were talking about classes and objects. So let's talk about rectangles today. So I want to define a class called a rectangle. And what is a rectangle? What you know, you meet someone who's a rectangle, what do you expect that to mean? What characteristics do they have?
The base and height.
Yeah, base and the height.
two sets of parallel sides.
Yeah, two sets of parallel sides, right? 90 degrees.
A color.
And what?
A color.
And a color and a thickness and a texture. These are all parts of rectangles, right? And some rectangles will introduce those parameters as well. But let's think of a rectangle as having a height and a width. And these could be integers, they could be real numbers, so let's make them reals. And in Java, we'll stick with doubles. So just like C, your floating points can be float or double. Double is double precision, and most things use doubles by default. So in C, we could say struct rect, curly bracket, double height, comma, or semicolon, double width, semicolon, close curly bracket, semicolon. And that gives us a rectangle. And then we could say struct rectangle R equals, or struct rectangle star R, right? And R is a pointer to a struct rectangle. And then we could say R equals malloc size of struct rect. And then we could say R dot height, R dot width. And now we have this variable R that contains two pieces of information, a height and a width. And we can pass R to a function, and that function can say argument.height, argument.width. It can get to those different fields. Okay, same thing going to happen with classes and objects. So we're going to define a class called a rectangle, and the corresponding object might be something like R. So we can say R is a rectangle. And we haven't actually made a rectangle yet. We haven't initialized R. We've declared it to be a rectangle, just like integer I declares I to be an integer, but we haven't given it an initial value. So in C, we'd say I equals 0. That actually initializes I. In Java, to initialize R, we use this new keyword, R equals new rect, with parentheses. And depending on how the class is set up, we may or may not need arguments to that constructor. So once we've done this, R is an object of type rectangle. Rectangle is the name of a class. Okay, it's just terminology, but we're going to use it so much. You want to be thinking about things in terms of objects and classes so that we can toss these around and know what we mean. All right, well, let's make some rectangles. So I'll make a class called rectangle. Rectangles. Eclipse will like do your spelling check for you also. It's kind of annoying sometimes.
A revolutionary shape.
Yeah. Or a fruit.
Square tangent.
Could be a rectangle or a fruit. That would be cool. Because they'd stack better on the palettes, right?
That's right.
Yeah. All right, so we're going to have a double height and a double width. And that's all I need technically to have a rectangle class. So let's make a main class. Okay, so this actually constructs a rectangle. And we could do it like this. Or we could do it on one line if we wanted. Just like integer I, semicolon I equals 0, or integer I equals 0. Same thing.
Would you do capital R?
I think So convention here, right? Classes start with an uppercase letter. Usually variables start with a lowercase letter. Variables meaning objects in this case. All right, so we have a rectangle. And this is not terribly exciting, but this will set the height and the width of rectangle R to be 5 and 7. And it should compile just fine. And I got a main.class and a rectangle.class. And if you run it, it doesn't show you anything, it doesn't do anything, but it did construct a rectangle, presumably, and set the height and width to 5 and 7. So this looks like a structure, right? R is a structure of type rectangle, and it's got fields called height and width. All right, so remember the cool thing about classes in Java is we can have code inside the structure as well. So here's a method, a function called area. And area multiplies the height by the width and returns that value. And so in my main program, I can say something like area of R equals R dot area. So R dot height is the value of the height variable. R dot width is the value of the width variable. R dot area is, in some sense, the value of the area, but it's not a variable, it's a method. It's the value of the area method, the value returned when the area method is run. What does the area method do? It multiplies the height by the width, and it returns it. Now, what height and width does it multiply? These. The height and width inside, in this case, the rectangle named R. If I had a second rectangle and I said rectangle 2 dot area, it would use the height and the width from rectangle 2. So this should return R dot height times R dot width. So we run that and it tells me the area of R is 35, which is what we want. And this looks different from C now. In C, we could have a function called area, and we would say area parentheses R, right? We pass R as an argument to it. And the problem with that is, what if R is not a rectangle? What if R is a circle? What if it's a linked list? And I try to pass it to this thing that's expecting a rectangle. The compiler may catch that, or it may not. With this, there's no question that I'm asking for the area of a rectangle because the area is part of the definition of a rectangle. And if I define a class called circle, I can have an area method for that. And I could say, circle C equals new circle. And then I could say C dot area. And it's not going to call this area code. It's going to call the area code in the circle class. So let's put one of those in here also. So circles have a radius. And I don't know for sure that it's math.pi, uppercase pi, but we'll find out. But that's how we get to the constant value pi. Math dot basically says where we find this variable, and there's a field inside the class named math, named pi, and it's equal to 3.14115, etc. But I bet I spelled pi wrong. Nope, I got it right. So I've got my rectangle R, I've got my circle C, I set the radius of C, I set the height and width of W, and then I'll call the area on R and C. And it does the right thing.
Safe to assume that the number that it printed is the size of pi in the math library?
It's usually got some extra digits you're not seeing,
Oh, okay.
but yeah, basically. And there's other ways to do output besides print line. Print line, we're letting it sort of make decisions about format and precision and so on and so forth. You can specify all of that stuff with other versions of print line or other functions like printf. Okay, so this is nice because in C we would need rectangle area and we'd need circle area. And in this first case we'd say rectangle area parentheses R. In the second case we'd say circle area parentheses C. Right? And then if we had triangles we'd need a function called triangle area and square area and polygon area. And here our area method can always be called area. Right? And we don't need to know what the name of a circle area method is. It's just going to be area. And if we have a circle, we can say name of the object dot area, and it runs that code. And we don't have to pass anything to it, and that's nice. All right, still with me so far? Okay, let's make some constructors, because every time we make a rectangle, we need to set the height and the width, and every time we make a circle, we need to set the radius. That's kind of a drag. So let's make a constructor. So to make a constructor, you use the name of the class. When you make a function, you have to say what kind of variable it's returning, right? Just like in other languages. When you make a constructor, it's the only case where you're defining a function without a return type. Okay, if I try to say void or int or something, it will complain. And if I don't say a return type for another function, it will complain. So constructors, you use the name of the class and then whatever arguments you have. So let's do the sort of obvious thing. Let's construct by passing the constructor the height and the width. So that's a way to construct a rectangle. And we'll make a constructor for our circle. So I'm going to say R equals rectangle 5, 7. I'm going to say circle equals new circle 1. And I'm going to comment all of this out. So we're still where we were. But our code, if we ignore the block of code in the middle that's commented out, our code is pretty short now, right? Rectangle R equals new rectangle 5, 7, and then we can say print R dot area. Circle C equals new circle parentheses 1, and we can print out C dot area. This is a whole lot easier to read than what the equivalent would look like in something like C, where we've got all these functions and we've got this mysterious way of constructing these things with malloc and so on and so forth. Bless you.
Could you, so to take in like input, instead of having like a hard number in there,
Mm-hmm.
could you do like rect arg1 and arg2? And
Yes.
circle arg3?
So we can pass command line arguments to this, and let's actually play with that. So I'm going to print out something called args.length. What does that mean? Args is an array. In Java, arrays have a field called length, and it tells you how many things are in the array.
You don't use parentheses after the length.
It's not a function call. And this is a little peculiar, because if this was a string and we want to know its length, we'd have parentheses, because we're actually calling a method in a string class. But arrays are a very special case. They come with a field, just like height and width in a rectangle, so we access the length field by saying args.length. And it's a bit of a almost inconsistency in the language, but it does the right thing. So if I say Java main, tells me number of arguments equals 0. If I say Java main, this is fun, tells me number of arguments is 3. So let's print out the arguments.
So we have to do for loops in this class?
Yeah. That would be a fun challenge. Teach the whole course without for loops. Yeah, that would be cool. Totally. All right, so basic for loop with I going up to number of arguments -1, and we'll just print out args bracket I. And this will do probably what you're really hoping it's going to do, which is the args array contains each of those arguments. That's the equivalent of argc, argv, right? But it's hopefully a little more natural to say if I want argument I, it's just args bracket I. And there's nothing magic about args, right? It's just a variable name. So that'll work the same. Yeah, talk like a pirate Dave.
Entry 0, not array, isn't the name of.
It's not the name of the function, yeah, so that's gone. So if there's no arguments, the length of the array is 0, which is kind of nice. Mm-hmm.
So for the concatenation,
Mm-hmm.
if you wanted to put the argument, like when it says this argument is, and you wanted to put is in quotes, would you have to do double quotes and then another double quote?
Around like is?
No, I mean, so like it says is and then plus, and then would you have to put like double quote, quote?
Oh, you want to put
around-
quotes around the argument itself?
Yeah.
Um,
Would that be a bunch of like?
Do you have to escape it?
that should work. Let's see if it works, then we can talk about why. Nope. So yeah, probably an escape works better.
And then wouldn't a single, or no,
Ooh.
Is it handling it like the first quote starts whatever you're not counting, and then the first quote it comes across is one? That's confusing.
Oh.
That's a confusing question.
Yeah. So yeah, the backslash in front of the double quote makes it just a single character. And so it's a single character between two quotes.
So it kind of follows some regex rules.
Yeah, yeah. Backslashes in most languages these days just escape the character that comes after it.
Oh, okay.
That's actually the origin of my 32 years of research life. Was the backslash in front of a double quote. Another story. All right, so this does what we would hope, and if we try to print arguments that are outside of the array, so let's just go up to 2 times the length, right? We get an exception, but it's a nice exception. Instead of just saying, you know, segfault, it tells us we're at line 10 in main.java. And we got an array index out of bounds exception. There's a hint in there to what's going on. And it even tells us that the index was 3, and that's what caused the problem. So we tried to access element 3 of an array at line 10, and there was no element 3. That's too big for the array. And so here we are at, here's line 10, and right now, you know, okay, so I must have been equal to 3, and that's bigger than the array. And it's like, oh yeah, because I typed a 2 star up here.
Can you use GDB with these files?
There's a JDB,
Maybe.
but I've never had a lot of happiness with JDB. But Eclipse has a debugger built in that's really nice to use. You can set up watch points and breakpoints, and you can look at the values of variables and watch them while the code's running and all kinds of stuff. So we'll play around with that, definitely.
Is it kind of like NV Lab or whatever from 2
Similar idea, yeah, because it's inside this integrated environment.
Do you have to convert a number from the arguments, the argos?
Yeah, so the original question was, what if we wanted to construct using arguments? There's a link to the Java doc on Canvas, but I don't use that link. So if I want to know about integers, for example, I'll just say Java integer. And usually the first thing that Google brings up looks like this. Java Platform, Standard Edition 7, Oracle Help Center, the name of a class. That's usually pretty good. And without getting bogged down on details, there's a thing called Parse Int, and it takes a string and it parses it as a signed decimal integer, and it returns an int. And that's what we can use. Now Parse Int is inside this class named integer. It's a method. And so if we want to use it, here's what we get to do. So let's comment this out.
Are the 3 stars for funsies, or is that how you comment out?
That's just for funsies, yeah.
Okay.
Get your pirate speed.
Yeah. 4 R's.
That's not too bad.
That's what happens when you recklessly repeat.
Yep.
I feel like it's still easier than C.
Yeah, yeah.
Let's see, we would add a ODP on making a parse.
Yep. All right, so I don't know if this will compile or not. It may complain about unchecked exceptions, which I wasn't ready to get into today, but this would be the idea. Take your first argument and use the parse int method in the integer class to convert it into an integer. Except I wanted doubles, didn't I?
We'll choose another class to switch it into a double.
We could just switch it over. Or we can look at the double class.
Twice as fun.
And there's a parse double method. I'm curious if this will actually work, so let's try it. Ooh, did not like that.
Do you have an extra bracket after the common block?
Yeah. Thank you. So I just run main, I'll get an error because it's looking for arguments and I didn't put any in. But if I put on some arguments, so let's do a 12 by 15, and there's my 12 by 15 rectangle. So pretty easy to do, right? Instead of like fgets and scanf and all this stuff, right? Pretty straightforward. If you want to convert to a double, you use a parse method from the double class. If you want to do an integer, you use a method from the integer class, and so on. Okay, I'm going to post this code up on Canvas later on. So this will be main with parser.java. And I'm going to get rid of a bunch of this stuff so we can concentrate on something else. All right, so there's our code. Well, that's not too bad. There's an issue though. So let's make a function. Suppose we have a rectangle like this. And suppose this rectangle is 4 by 9. So what's its area? 36, good. I don't have to ask that on the final then. So area equals 36. For any rectangle, there is a corresponding square with the same area. Agreed? So we could always square a rectangle and come up with a rectangle that has the same total area as the original, but has the same height and width. And that's not hard to do, right? Compute the area, take the square root, that's the height and the width. So let's make a function, a method, for squaring a rectangle. And this is a void method. It does not return anything, and it doesn't take any arguments. It just does something to the rectangle. It's going to change the height and the width. So I'm going to calculate the area by multiplying the height and the width. I'm going to take the square root of the area and set that equal to the height, and I'll set the square root also equal to the width. And that should give me a square. And is this going to do anything useful for us? Probably not. So let's put a perimeter method in our class also, so we can get an idea. I probably spelled perimeter wrong.
You forgot an L.
Well, double's harder to spell than perimeter. All right, so we're just going to take the height plus the width and multiply by 2. All right, so I'm going to ignore the circle for now. So we're going to construct a rectangle. I'll make it a one-line construction. We'll print out the area, we'll print out the perimeter. We'll fix our errors. Oh yeah, I forgot to tell you how to do square roots. So there's a square root option available in Java, right? But Java does not have a sort of arbitrary library of random functions, right? In C, we know that there's a math library, and if we say -lm when we compile, it'll pull that in, and we can do square roots and arctangents and things like that. It's a little better organized in Java. There's a way to get square roots, but we have to tell it where the square roots come from, and they come from a class called math. And so if we say math.squareRoot, we're asking for a method named square root in this class called math. And the math class, right, it's just another class, but it's got some static fields like pi and e, and it's got a bunch of methods, absolute of doubles, floats, integers, longs, and so on, add exact, that's kind of nice, and arcsines and ceilings and cosines and so on, and somewhere down here is a square root. So return the correctly rounded positive square root of a double value. And you can click on these things and get more details. All right, so this will give us square roots of numbers. So we should be able to compile. And if we run, there's our rectangle. It was a 5 by 7, so area 35, perimeter 24. So let's make this thing. What did we do? A 4 by 9.
Are all the functions inside of the class considered methods except for the constructor?
Yes.
Or is the constructor being a function?
Yeah, so you've basically got data and you've got methods. So any of the functions, any of the runnable code, those are methods, except for the constructor. I don't know if the constructor is technically considered a method or not. It might be, but I don't think of it as one. All right, so Java main, we've got a 4 by 9 rectangle, and it tells us the perimeter is 26, right, which makes sense. So 9 and 4 is 13 times 2 is 26. If we successfully square this, we should end up with the same area but a perimeter of 24. Right, that's how you minimize the fencing you need to enclose a certain area. Calculus problem. So let's look at our square function. Method for squaring the rectangle. We'll calculate the area. We'll set the height and width to the square root. So in here, how do we square this rectangle? R dot square. And then we'll say after squaring, we'll see what the area is, what the perimeter is. So after squaring, the area is still 36, the perimeter changed to 24, which is exactly what I wanted to do. So we're going through a lot of concepts really quickly here. We'll spend more time with more details on them in the coming classes, but I want to get you on the air for PA1 so you can start making some inroads on that. So is this making mostly sense? It's okay if it's still a little fuzzy or not quite 100% solid, but higher level concepts hopefully are clicking. Well, let's make some changes to this. No need to do extra typing. I can do width equals height equals and set them both equal to that square root, and that'll work fine. But what else could I do to try to shorten this particular method?
Call the area method?
I could call the area method. What am I doing up here? I'm calculating the area. Well, I've already got code to calculate the area. It's a method called area. So here's what I'm going to do. I'm going to get rid of this. And I'm just going to call area. And that'll work perfectly fine. So what's the logic here? In our main program, we say square. It's a method that's part of R. So R is an object of type rectangle. When it says r.square, it's going to go into the class definition for a rectangle and look for a method named square. So here's a method named square. It matches the signature, right? It has no arguments. It's got the same name. So it starts executing this code. Well, the first thing it does is it calls the area method, which says take the height and the width, multiply them, and return that. Which height and width? The ones inside R. Right? That's the object we're working with. So this is equal to the height times the width. It feeds that to the square root method in the math class, which computes the square root, returns that, sets width and height equal to that. Again, which width and height? The ones inside R. And now we've squared our rectangle. All right, and I'll show you how we can get in trouble, and then we'll take a break. So suppose the user decides to change the width of the rectangle. And they've got some fancy function that does some calculation to decide what the width should be. And it eventually assigns the width to be -10. And now when I run it, I'm getting these nans, not a number. Because a rectangle that's -10 by something technically has a negative area, because we said the area is just the product of the height and the width. It's got a negative area, and when we try to take the square root, that's not a real number. So it gets replaced with a nan, and the perimeter is nan. And if I'm using this to do something like increase the pressure in this pipe until it's equal to the area, and I keep increasing the pressure and adding 1 to a number, and it's never going to be equal to nan, and it's going to keep increasing the pressure until the system fails. It's a weird example, but you get the idea, right? This is not something that we wanted the user to be able to do. We didn't want them to be able to give us a negative width. So what can we do about that?
Multiply by -1.
But when would we multiply?
If it's negative input from them.
So we could inside our squaring function, we could check to see if the number was negative, and if it was, we could replace it with a positive. And we could do the same thing in the perimeter function, and we could do the same thing in the area function, and we could, in all of our code, do these checks to make sure the user hasn't done something silly. But that's kind of a pain.
Could you just take the absolute of the value?
We could do that. That would work great in this case. But if there was something else going on, like if we only wanted to allow even numbers, or if the conditions were somehow based on something else, it might be more complex than that. So let me show you a really simple way to set this up, and then we'll take our break. Keyword private. When I say private, and then I list a variable, it means nothing outside this class has access to that variable. And when I try to compile main, it will complain. It'll say, hey, you're trying to access the width variable inside a rectangle, and that's private. And so this kind of protects the programmer from themselves, right? And it's part of a larger concept called information hiding. It's basically trying to put bounds on what a user can do inside your class. And we've talked about this in 222. You're making a stack class. So you have a stack pointer and you have an array, and you want to initialize the stack to 0. You never want the user to write code that says something like stack.sp equals stack.sp plus 1. Because the user may not know if you're supposed to add 1 or subtract 1 from the stack pointer when you push or you pop, right? That's stuff that we as the programmer take responsibility for, and we really don't want a user of this data structure to monkey with those details. So abstract data types, you have a set of interfaces, functions that the user uses to interact with your data structure, and that's ideally it. They don't go on the other side of this firewall and start monkeying with SP or with star root dot next or anything like that. And so one way we can do this is by making certain variables private. All right, so let's take a quick break. We'll come back a little after 1, and we'll see how to work with these private fields, because we have to add some other things to make this practical.
My class, I didn't write Java.
All right, so we have this private keyword that we can use to lock down access to variables, and now outside code, right, another class like our main class can't get to height and width. That's nice because it lets us control height and width, but what if the user wants to look at the values of height and width, or change the values after they've constructed the rectangle? Because they may very well want to do something like set the width to some other number, hopefully something reasonable, right, like that. But they can't get to the width because it's private, and private means no read access, no write access. You can't do like read only. So the way we do this is we make some more methods. And this may look a little heavy-handed, but it's a very standard thing to do. So we're going to make what are called accessors and mutators. Access gives you access, and mutate lets you change. So we're going to make a method called setHeight, and it's going to take an argument, we'll call it h, and all it does is say height equals h. And now if we want to set the height of a rectangle, we can just say rectangle.setHeight and give it a number. And we can do the same thing with setWidth. So those are mutators.
So if you wanted to make sure that they weren't negative, we could do that in the.
So we can do that in here, right? Because the only way that they have access to changing the height is by calling our setHeight method. And so we can do something in here like say, if h is less than 0, h equals negative h.
Is the order in which you put like the constructor and
Doesn't matter.
okay.
There's a few things later on where certain things will have to go first, but in a general class, doesn't make any difference. So I'm sort of putting the newer stuff at the top. Okay, so those are mutators. Accessors have an even simpler task. Get height. Just returns the height. And get width just returns the width. And Eclipse will construct accessors and mutators for you if you want. It's a really common thing to do, so you can just say do it and it'll make a get this, set that. So here I can say r.setWidth 10. Right, and that works fine. And if I set width to -10, it'll just replace it with a +10, and everything works the way it should. We got a rounding error out here, by the way. Got an extra one there on the very end. So my 10 by 4 turned into a 10 by 4 point something. That's one reason we stay away from floating points sometimes. All right, so information hiding is the buzzword here, right? It's giving the user a very specific set of ways to interact with your class and restricting access in all other ways. So here's another example of where we could use this. Suppose that we care about units and we want to create a rectangle class that works in inches. So when you say rectangle 4:9, you're making a 4-inch by 9-inch rectangle. And that might matter because maybe we can compute like the cost of building this out of wood or something. But internally, instead of using doubles, we might want to use integers. And we might convert that 4-inch and 9-inch into millimeters and store the number of millimeters as an integer. And then we wouldn't have these potential rounding errors, right? Does the user care that we're doing that? Presumably not, right? But if the user wants to change the rectangle to be 10 inches and they say r.width equals 10, and we're storing these dimensions in millimeters internally, they just made a really tiny rectangle, right? And then if next week we decide we're going to store these dimensions in kilometers, now they've made a really big rectangle. So we don't let them interfere directly with the height and the width. We don't let them interact with that. They have to go through our mutexers and accessors, and we can do the right things, error checking, conversions, sanity checks, whatever, when they're working through those methods. Okay, so accessors and mutators. And you'll see these a lot throughout the course, and you'll see them anytime you work with Java. Mm-hmm.
So you have to do the same like checks in the constructor, right?
Yeah, we should put these in the constructor also. We'll just write a comment. And in practice, you might make a method that takes a height and a width and does whatever sanity checking you need, whatever conversion, and so on and so forth. And then we could call that method in the constructor. We could call it in the set height and in the set width, and anywhere else that we needed.
So
Right.
couldn't you just do height equals set height h?
That's a good question. So yeah, I think we could just say set height h and set width w. I think that would work.
Hopefully. You wouldn't have to have the same error check in there as well.
I don't see any reason why I wouldn't like that. Cool. Code reuse. Awesome. Now if you wanted to be able to construct a square, right, we could make a rectangle constructor that takes a single argument with the understanding that if you make a rectangle with just one argument, that's the height and the width, and it makes a square with that for both dimensions. And we just make another rectangle constructor, and we'd be good to go. All right. So let's change gears a little.
Are we gonna talk about other like system.out functions?
Oh yeah,
Is there a system.in?
there is. And if
Is it how you read what the user wants?
yeah, if you want a preview, right, you can look at the system class.
I can hear your word expected.
Yes.
Yeah,
Is that mean?
Is there system.error?
and there's a system.error. Yeah, I believe. So system.out, system.in, system.error. Those are fields within the system class. Standard in, standard out, standard error. And there's all sorts of trouble we can get into here.
Name time?
Yeah. All right, so yeah, we'll talk about those in a week or two. Lots of input and output. All right, so what's going to happen here? I'm saying system out print line r equals plus r. We said plus is this magic concatenation. And we can take an integer and a string and a double, and we can put pluses between them, and it'll just glom them all together, and it'll print it out in a pretty format, right? So what's going to happen in this case? R is a rectangle. It's 4 by 9. I'm going to say print out the value of r tacked on the end of this string r equals sign. And it gives me something not quite as horrifying as we get in C, but it says r equals rectangle at sign and then a hexadecimal number. Ooh. Okay, this is the best it can do. It's telling us that r is an object of type rectangle, and it's got some sort of internal data structure inside the Java virtual machine for tracking which rectangle r is, and that's the number that it's using internally to identify it. So if I make a second rectangle, I'll get a different value for that. But this is not very useful to us. But it does something, right? It concatenates something to R here. But we'd like to concatenate something more interesting, like maybe the dimensions of the rectangle. That would be a little more useful, right? So here's what we can do in Java. We can make a method called toString. Takes no arguments, returns a string. If we put a method in our class with this signature, when we try to concatenate an object of that type, it will call this method, and whatever this method returns, that's what it will concatenate. So let's see that in code, because it'll be a little easier. And this has got to be defined public. And what should we return when we try to concatenate a rectangle? I don't know. A rectangle. All right, so all we're saying is r equals, and we're concatenating r to it. And when it says r equals, I'm a rectangle. And it doesn't really care what toString returns. Whatever it returns, that's what it will concatenate. So we could have a cow, say, in the middle of there, and we could capture it with some new lines on the end and concatenate all that, and our object would look like a cow, which would be pretty awesome. So let's make it return something more interesting. How about this? The height followed by an x followed by the width. So now when I run my code, it says r equals 4 by 9. So when we create classes, for things other than, you know, a simple integer. When we have more complex structures, we may have some idea of what we want them to look like if somebody tries to print them. And by putting code in this method called toString, we can create whatever output we want when the user concatenates this to a string. And what's going on here is a lot more involved than I've described it. It's got to do with something called class extensions. And I don't want to get bogged down on them today because we're going to spend probably a good part of a week talking about class extensions in detail. I talked about it a little at the end of the previous class, so if you are really curious, you can watch the video ahead of time. But the basic idea is that every object we create has a toString method by default. And the toString method that's available by default prints out the name of the class, an @ sign, and that internal hex code referring to the object. But when I write my own method named toString inside a rectangle, it overrides the default toString method. And classes that we create usually come from other classes. So there's a superclass of everything called an object. And even though I said class rectangle, it's really a descendant of this bigger class called an object. And you can look at the documentation for an object. It's a class, and one of the methods that you get with that is called toString. And when I write toString in rectangle, it takes the place of that object.toString. But class extensions are everywhere. So we'll talk about file writers, for example. And a file writer is really an output stream writer with some extra stuff added in. And an output stream writer is actually a writer with some extra stuff added, and a writer is actually an object with a lot of extra stuff added. So writer extends object, output stream writer extends writer, and file writer extends output stream writer. And this is pretty standard when we build classes. We usually don't start from nothing. We start from at least an object, but we may start from, you know, something more complex and add on our own stuff. And that's a really powerful programming model. All right, questions so far? Yeah.
So when you do system.println,
Mm-hmm.
you have to use 2 dots. Is that because out is a field in the system?
Yeah, so let's. So system.out is a print stream. And if you look at a print stream, if we're lucky, it has a method called println. So this is like something arrow something arrow something, right? System is a class. It's got a field called out, which is itself a class, which has a method called println, right? So we're dereferencing multiple times. And so these are all the things we could put after system.out. So different versions of print and different versions of println and so on and so forth. And the flush and close and all the stuff you expect with outputs. And if you look at system.in, in is an input stream, and an input stream has all of this stuff available to it. So there's a read, and we can read bytes, and we can read arrays, and we can skip over input and so on. And we'll spend several days going over, well, not several days, but you know, a week's worth of lectures going over different I/O and such available in Java.
So there's no real, like, Java just kind of has a read-in thing where C, you have to be careful about which one you have, otherwise you'll get garbage data or corruptible data or something like that. Java just says 1 and it takes it in. And
Sort of. I mean, so does C in some way. Java, we can read from standard in, right, system.in, but we can choose to do a number of things with it, right? Parse it as an integer, parse it as a double, or break it up on spaces or things like that. But it's all going to be done in the same way, which is by using methods in classes, basically, or in objects.
So if you didn't want rectangle data from standard in, would you use a class that was like file open or something?
Yeah, so there's a, it's exactly called file. And you can construct it with the name of a file, right, a full path name, or a URI. And then you can do all these different things. And the things that we do for I/O will work with files as well as these input streams, output streams. It's actually a really convoluted system. And as with many things in this sequence of courses, I'll try to cut a particular path through all of the possibilities and give you a set of things that will work, right? But it's really just the narrowest path through what's, you know, probably a 2-course sequence just on the I/O system of Java. That's an exaggeration, but not too much. All right, so let's look at programming assignment 1, because you probably know enough to be able to do most of this. And figure out how to get rid of this. That works. All right, so so programming assignment 1, you're creating a new type of variable for Java. It's a fraction. And what is a fraction? We're only going to work with rational numbers. Okay, so a fraction, it's some sort of numerator over a denominator, where these are integers. And nothing weird here, it's just what you think of as fractions, 1/2, 3/4, -2/3. Those are the kinds of things we want to talk about. But our goal is to create basically a type of variable called a fraction and be able to do things like add, subtract, multiply, divide, and print fractions in a reasonable way. Okay, this is not part of the language by itself. There's integers, booleans, doubles, and so on. There's no fractions. So we're extending the language. And we're going to do this in the way that we choose, or the way that I choose, I guess, which is what PA1 is. So think about fractions as an abstract data type for a minute. Somebody wants a fraction ability in Java, and so you're going to give them this class called fraction. And what sorts of things do they want to do in working with fractions?
Add, subtract.
Yeah, so
Simplify,
add,
whatever.
subtract, multiply, and divide.
Simplify.
Simplify. So least common denominator. There's Euclid's algorithm coming back. What else? I already gave you one.
Two-string.
Hmm?
Two-string.
Two-string, sure, print. We'd like to be able to print them out in some reasonable form. You may want to be able to get the numerator and the denominator, or maybe not. But I can imagine if you had fractions, you might want to know, like, what's the numerator of this fraction, what's the denominator. Anything else? Again?
Real number?
Real number, okay, so let's call this 2 double. Let's be able to convert one of these fractions into just a plain old double precision variable. So if you have the fraction 1/2, I'd like to be able to turn it into the number 0.5 so I can do other things with it. And the other side of that, of course, we want to be able to construct fractions. So say, give me a fraction that's equal to 3/5. Now, as we talk about, and this is basically what you're going to write, right, is a way for the user to do these things. But you're going to have a lot going on below all of this, right, on the other side of the firewall that the user is prevented from accessing. So for example, it's going to be really, really useful if we always keep our fractions simplified. Right, it's going to keep them from getting too big. It's going to put them in a known state. It's going to make it easy to do things like detect if the fraction is equal to 0, or detect if it's positive or negative. So when we have a negative fraction like -1/2, it could be -1/2, or it could be 1/2. And if we don't know which one of these is being used and we want to know if our fraction's negative, we have to say if the numerator is negative and the denominator is positive, or the numerator is positive and the denominator is negative. If we decide, for example, we're always going to use this format, it's really easy to tell if your number is negative. Just check the numerator. But if we let the user set the numerator and the denominator by hand, they might set your number to look like this and break our code. Okay, so this is a case where we're not going to let the user explicitly set the numerator and denominator unless they do it through our methods. And our methods will do things like make sure that things are in simplest form, and make sure negatives are in a format we want, and by the way, make sure that we don't have a fraction like that, or if we do, that we're aware of it. So there's a lot of details here, but that's the basic view of what we're after in PA1, is a fraction class. Okay, so you're going to create a new class named fraction for managing fractions, rational numbers. You're not going to turn in a main program for this class. You're just turning in the class fraction. Okay, and it's going to have inside it everything that you need to make that class work. So it's going to be a single file, fraction.java. But you're going to want to make a main program to test your code. Right, so you're going to want to construct some fractions, give them values, add them, print them out, and so on and so forth. And I'll give you some sample main code at the end of this. But your deliverable is the fraction class itself, fraction.java. Okay, there's two constructors, one that takes a numerator and a denominator, and there's a second constructor that just takes a numerator and assumes the denominator is 1. If you want to make a bunch of fractions that are integers, you don't want to have to put the 1 in there at the end. So you can charge more for your package because it's got two constructors instead of one. Okay, adding fractions. So imagine we have something like fraction a comma b comma c. That feels horribly fuzzy to me.
It's a tiny bit low res.
Yeah. It's a tiny bit not cooperating.
Just a tiny bit.
All right, we'll figure it out later. So suppose a, b, and c are fractions, and we want to add a and b together. So a is a fraction, and it has methods inside. Let me see what I want the method called. Add. So I can say a dot add, and I can give another number that I want to add to it. And this should take the fraction a, it should add the fraction b, and it should return a new fraction. And so this should be legal. And this is just doing c equals a plus b. And same with subtract, multiply, and divide. So we have some methods. And in the description of these, we're assuming x is a fraction. So x dot add takes a fraction n and returns x plus n in reduced form as a fraction. Subtract, multiply, divide, do subtract, multiply, and divide. To double, a method of a fraction returns a double precision number which is equal to the fraction. A pair of accessors, so get num and get denom, will return the numerator and denominator, just in case the user wants to see those. Our toString method, which will return a string corresponding to the fraction, so we can print these things out in the usual way. And toString, there's a little section down here that tells you exactly what format you want it in, but it's basically a reasonable looking fraction. Okay, you probably want a private method called reduce. And reduce simply conditions the numerator and denominator to put it into a form that makes sense to you. And I'll describe a way that makes sense to me to condition your numbers. You don't have to do it like that, as long as the final behavior is correct. But I think it's easiest if you do it the way that's described in here. But as usual, you have a lot of leeway in how you want to implement this. Okay, so for reducing a fraction, use Euclid's algorithm, which will be discussed in class. Well, I don't want to discuss it today, but we can talk about it. Reduction you can add in kind of at the end, right, if you like. Basically, every time you construct a fraction before you return, just call your reduce method. So we can leave that one for the end of class or for Tuesday or for a discussion on Canvas. Division by 0. So technically, when you try to divide by 0, that's an illegal operation. Okay, we're not going to blow up. We're not going to seg fault. We're going to leave the number with a denominator of 0, but we're going to treat that number differently when you try to add, subtract, multiply, or divide. So what's our usual way of operating on fractions? Multiplication is the easiest. Multiply the top, multiply the bottoms. And then reduce. So if you do 1/2 times 2 over 1, you'd like to end up with 1 over 1, not 2 over 2. Right, division, you just flip and multiply. And then addition and subtraction, you just find the common denominator, a common denominator, and you normalize and add top. Keep the denominator on the bottom, and then definitely reduce. Okay, but if we have a fraction with a denominator of 0, that's undefined. And the rule in here is that any time you do any operation with an undefined fraction, the result is undefined. So 1 over 0 minus 1 over 0 does not give you 0. It gives you an undefined number. 1 over 0 times 2 does not give you 2 over 0. It gives you an undefined number. You may represent that as 2 over 0, but in the end, we want it to be an undefined number. Okay, so that's what this is talking about here. Any operation involving an undefined number results in an undefined number.
Does that mean you return an error?
You don't return an error. We don't have to really do anything with it as long as we have a way of knowing that it's undefined. So the only time it really comes up is if you try to convert this to a double. And if you convert it to a double, you should return what's called not a number, double.nan. And that's a legal value for a double variable to hold, double.nan, not a number. And so that's what you want to return, and that'll automatically retain its value when you operate.
So it will be automatically like will be shown like nan.
Say again?
I mean, you don't need to like make some code like about that, right? For nan.
So no, if you call to double and it's got a denominator of 0, just return parentheses double.nan.
It's like earlier you show like in case of minus, negative, like something output.
Mm-hmm.
So in case this result was nan, but also like in the case like 1 over 0 or something like that also can be.
I think if you have doubles and you divide 1 by 0, I think the system will give you a nan. Maybe not, but we're going to.
When you return double.nan, that's what it prints as nan?
Yeah, it'll actually print as nan.
Okay.
And if you try to add something to it, it'll still end up nan. And if you subtract it from itself, it'll stay nan. So it's a reasonable way of dealing with things that are not numbers.
When I did dividing like something by 0, and I did a double,
Mhm.
got infinity.
Oh yeah, that's right. Java has an infinity and it has a negative infinity. So it'll do that, but 0 over 0 might give you nan. Okay, cool. Yeah, so that's kind of fun. All right, so the toString method, we want to print things reasonably. So if your fraction is 2 over 1, don't print out 2/1, okay? Just print out 2. And if your fraction is, 6 over 3, don't print out 6/3. Print out 2/1, no, print out 2. Okay, if it's 12/9, don't print that out, print out 4/3. So print it out in reduced form, and this is why it's easiest if you keep it reduced to begin with. And with negatives, if your numerator is 5, and your denominator is -3, and you ask to print this out, don't print this. Okay, that gets you the frowny face. Move the minus sign in front. So part of your normalization, it can be useful if you always put the minus sign in the numerator. Similarly, if your fraction happens to look like this, you really don't want to print this. Right, that's the double frowny face. So if at some point you find the numerator and denominator both negative, change them to both positive. Store it like this, and then when you print it, it'll just come out like that. So you want reasonable looking output. And there's a lot of wordage in the assignment about what that means, but that's the gist of it. And if you try to print something with a 0 in the denominator, print out NaN. Okay, this is for your toString method. So you're not printing, you're returning a string, but return NaN. All right, and reducing numbers, the other suggestion is if you have a 0 in the denominator, set the numerator to 1. It makes it easy to tell that you've got an illegal number. And you don't have to reduce anything, right? Because but you can do what you want. But the problem is if you store your number like this, and I decide to make a loop that adds 1 over 0 to itself 1,000,000,000 times, and you dutifully say 1 over 0 plus 1 over 0 equals 2 over 0 plus 1 over 0 equals 3 over 0, I might get your code to blow up. Right? So when you get a number like 2 over 0, if you change that to 1 over 0, then I can call that 1,000,000,000 times and not trick your code into failing. I won't actually do that, but I could.
Are you wanting to change your negative signs in like set num and set denum?
You can do it there. Code reuse. So if you write your reduce function correctly, or maybe condition or something like that, right, it can put things in lowest common form. It can move negatives to the top. It can get rid of 2 negatives, and it can change not a number to a 1 over 0. If you put that in a separate method, right, you can call that inside your constructor, and then you only have to write the code once inside that conditioning code, and call it in the constructor, call it every time you create a new fraction, and that should be enough to make sure your fractions are always conditioned. So there's a pretty good element of sort of planning ahead of time before you actually write too much code, right? You can do an initial version of this without a lot of the fine details, just to get your feet wet and get something running and get some fractions coming out. And it's pretty fun when you actually get this working, right? Because you've made a new type of variable. And then it's probably good to sort of like do some strategic planning on how you're going to handle all of the nuances. One way to do this, and I've seen students do this in the past, is every time that they do something, they write 30 lines of code to do Euclid's algorithm and to move minus signs and that kind of stuff, and they end up with 500 lines of code for their fraction class. That's not necessary, right? if you think ahead of time about what sorts of things you want to do and you bundle those behaviors into methods and then you just call those, your code comes out not only shorter but easier to write and easier to debug. So some initial coding to get you running, and then some strategizing on how to sort of organize the finer details, and then more coding to implement that. Might be a good strategy. All right, so I'll show you a grading rubric here. 100 points. 90 points for behavior, 10 points for documentation. So if the code works perfectly, meaning I run it on my test code and everything works the way it's supposed to, there's 90 points. If most of it has been implemented but there's a few glitches or errors, 70 points. If there's a lot of things that are unimplemented, that'll be 50 points. If there's not a whole lot at all, that's 30 points. And if there's really nothing usable or you don't submit, that's 0. So pretty coarse grading buckets here. Documentation, 10 points. What do you have to do? Put a header in the beginning of the class, okay, with your name, the assignment, the course, description of the class in your own words, okay? Each method needs to be described in the beginning of the method. So tell me what the method's name is, what it does, the side effects, the arguments it expects, the things it changes, etc., etc. And comments throughout the code. X equals negative X, comment, change X to its negative, don't need to see that. Okay, denom equals minus denom, comment, negative fractions are stored with the negative in the numerator. That's a nice comment to have. Right? 3 months later, why did I say denom equals minus denom? Well, now you know. So reasonable comments on each line, that gets you 10 points. Okay. Header block, but not a lot of commenting in the code, 7 points. Header block present, but no real commenting inside, that's 3 points. No header block or things missing from the header, that's 0 points. Okay, so coarse buckets again. So here's some sample code. This is a class called fraction test. It's got my usual public static void main, and I basically make a bunch of fractions and do a bunch of operations on them. So A should be 1/2, B should be 4, C, D, and E are fractions. 5/2 should be what I get when I say print out a new fraction with a numerator 125, denominator of 50. C should be A plus B, which should be 4.5. And then let's see, print out a fraction 1/2 multiplied by a fraction 2, that should give me a 1. Okay, print out C, that should give me 9/2. And what I tried to do was before I print this thing, I show you what value I'm expecting to see, right? And some of this might change a little bit, but you got the idea. And look at what's going on in here. This new fraction 1, 2 dot mul new fraction 2. So new fraction 1, 2 is making a fraction equal to 1/2, right? That's calling the constructor. Once we have a fraction equal to 1/2, it has a multiply method. And we're calling that multiply method, and it expects a fraction as an argument, and we're constructing a fraction equal to 2 and passing that as the argument. So this line is saying make the fraction 1/2 multiply by the fraction 2. And we're taking all of that and we're saying concatenate that to a string, which means it'll call the toString method, and this should just turn into the string 1. And we can do a lot of things with these objects, right? We don't need to assign them to variables to use them or to access their fields or to access their methods. We can do things like this, and it's perfectly legal, and it's actually really nice. If you've ever done anything in Lisp, this starts to look a little Lisp-like in some ways, which is a good thing. All right, same thing down here. I'm making a fraction 1/3, and I'm calling the toDouble method, which should give me 0.333, and I'm concatenating that to a string. And so on and so forth. So that's just a sample main program. Don't get bogged down in the details of it, right? Write yourself some simpler main programs to start testing the basic functions. Once you think your code is looking pretty solid, this will do some of the more subtle things. Okay, so it's more like a later down the road test. All right, submission, make a tar file containing fraction.java and go ahead and submit that to Canvas. Any questions? So how do you start? Fraction.java, class fraction, curly bracket. And then just fill in the rest.
That sounds easy.
Yeah. It's really, right, it's a single class, but it's got a whole lot of different pieces to it, right? Certainly you're going to have a numerator and a denominator, okay, and those are going to be integers most likely. And then you've got some code. So make a constructor. So I would, if I was doing this, I would make a constructor and I'd make a toString method. And I wouldn't worry about too many of the details. If I get 5/-3, I wouldn't worry about it too much, right? Just because this may be the first sort of, more complex class you're building in Java. Just get something so you can make some fractions and print them out. That's pretty cool by itself. And then make a multiply method, right? It's 1 or 2 lines of Java. Multiply the top, multiply the bottom, make a new fraction. But it's going to have you calling constructors inside your methods, and that can feel a little strange. But just carve off little pieces of the assignment and get those working. And if you have a fraction.java file that you can compile, and you can construct fractions from a main program, and you can do 1 or 2 things with them, right? You're past 60% of the work, because it's all the sort of first steps of getting everything lined up just right, figuring out how to construct and so on. That's probably where most of your effort will go. Once you've got that working, then you're just writing code. Okay, you're not struggling with Java syntax, you're not struggling with object concepts, you're just writing code. And it's kind of like a 224 problem at that point. More details, but the sort of terrifying part is behind you at that stage, if there's terror involved. So you should be able to get going on this. Definitely discussions in Canvas, emails to me. Friday's 10 o'clock class is an open lab set up again, just like last quarter. So if you're free at 10 o'clock and you're having issues, you can come in and work on code then. Office hours. And I'm also teaching 250, so I have 3 hours of lab on Fridays from 12 to 3. So I won't be in my office, but I'll be sitting in the collaboratorium, and you can always catch me then, and we can talk about 223. All right, good to go?
It's toString
Cool. I will see you next time then.
plus.
Is it basically going to be a